The more we write new codes, the more we need to test. So we should try to reuse code as much as we can. In practice, it is often to see the hierarchical relationship among objects, so a child can reuse what the parent has to avoid repetition. This is inheritance that we can have from Java. We continue with our example on banking accounts. Now let's suppose we want to have a saving account. So the saving account is very much like the bank account that we saw, that it has an account number and balance. On top of that, it has interest rate, that the account receives interest at this rate. And the basic functionality includes withdrawal, deposit and print, just like as in a bank account, and it pays interest. Compared to a bank account that you saw in the last video, the main differences are highlighted in both fonts, the interest rate attribute and the pay interest method. So saving account actually shares lots of code with the bank account. So the question is, should we just cut and paste the code from bank account to saving account or not? We're going to see that it is not advisable to cut and paste. This is to avoid maintenance issues of correcting and modifying many copies of the same kind of codes. So object-oriented languages allow inheritance. So you declare a new class based on the existing class. In this case, you declare a saving account based on the existing bank account. Then the new class inherits all of the attributes and methods from the other class. And the new class modifies or augments the inheritance to suit objectives of the new class. In this case, augment, like it added an attribute to keep track of the interest rate and a method to pay interest. The terminology is as follows. If a class B is derived from a class A, then we say that class B is called a child or a subclass of a class A. And A is called a parent or a superclass of class B. Here is how our saving account is going to look like with the use of inheritance. The class bank account was as this, except that now instead of private, we have changed it to protected so that the subclass can use directly the account number and the balance. Our subclass is saving account, which extends bank account, and it has also a protected double rate, and it has a public method to pay interest. So underscore balance, which is from the parent, in this case the bank account, and because the underscore balance is a protected double, so we can use it directly in the subclass. Let's say a few words to remind ourselves about the inheritance done. In the saving account, we don't need to repeat definition of our account number and balance, and we also don't need to repeat the methods withdraw and deposit. So we have saved in redundant coding. As a result, our coding so far is better maintained. Should we need to modify withdraw in the bank account, we just need to do it once, and it will also be applicable to the saving account. Also, because the bank account was not modified to suit the saving account, except for the change in the private variables to protected variables, all programs use bank account are not affected at all. They all should work as before. Note that constructors from superclass are not inherited to the subclass. A default constructor with no parameters is added by the compiler if no constructor is provided. But for our saving account, because of the interest rate, we may want a constructor that takes in the interest rate to be kept, and thus we should have our own constructor. Here it is, our constructor. It's public saving account with 3 parameters: account number, balance, and the rate. The protected variable underscore account number is assigned to a number, and the protected underscore balance is assigned to balance, and the protected underscore rate is assigned to rate. Here you see that there are 2 obvious repetition also. These 2 lines actually appear in the superclass bank account, and there is a way in Java to avoid such repetition by using the keyword super. So super allows us to use the methods in the superclass directly. So that 2 lines are now being replaced by super account number balance. So super is calling the superclass constructor with these 2 parameters to set the account number and the balance. And the last variable, which is available only in saving account, it's then set to the rate. This way then completes all the assignments of the variables. Let's see a simple usage of the saving account. Here is the public static void main again. So saving account SA1 is a new saving account with account number 2, balance 1000, and interest rate 3%. You can do SA1.withdraw $50, so the balance will then be $950. This withdraw is a method inherited from the superclass. You can then do SA1.pay interest. This is a method in the saving account class. Then you can do SA1.print. This print is inherited from the superclass. As this print only prints out the account number and the balance, it doesn't print the interest rate. We should next override this print method to also print out the interest rate. We have just seen that inheritance is not all useful to the subclass. We are allowed to change or extend the functionality of those inherited methods, and this is called the method overriding. In a saving account example, we need to override the print method to include the interest rate. To override a method, we simply recode the method in the subclass with the same method heading. That means that with the same name and the parameter types of the method. Here is how our print method looks like. Public void print, account number like this, balance like this, and the additional line, interest rate like this. Again, you see that these two lines are repeating what are already in the bank account print method. We can again replace it with a super keyword. Here is how the print looks like now. Public void print. This super top print is to call the bank account print method, and you print the interest rate separately. So this will print out the account number and the balance, and the last statement is added to print also the interest rate. This completes the print for the saving account. There is a subtle advantage of inheritance. Whenever a superclass object is expected, a subclass object is acceptable as an substitute. Therefore, all existing function that works with the superclass objects will work on subclass objects with no modification. This is the same as if you know how to drive a car, then there's no problem for you to drive a Honda car. Here is our bank example to show you what we meant. We had before a transfer method that transferred from bank account to bank account. Now, we can actually do a transfer from a bank account to a saving account with no issue. BA is a bank account, SA is a saving account. Saving account is a subclass of bank account. So the method transfer, which works on bank account to bank account, it's applicable to bank account to saving account as well. Actually, all classes that we create are actually subclasses of some other classes. There is a mother of all classes which is called the object, capital O object. And all methods that work with object reference will work on objects of any classes. A method defined in object class are inherited in all classes. To string is such a method that we see in our Java code. We use often in Java to convert integers, etc. to string for printing purposes. Inheritance is an useful feature, but one should not overuse it. To know when it is correct to use inheritance, here is a simple rule. You have to check whether it is a or it is has a. If B is A, then B is likely to be a subclass of A. On the other hand, if B has an A, then B should have A as an attribute. Here is what we meant. Saving account is a bank account. Therefore, we have saving account extends bank account. On the other hand, a person has a bank account. Therefore, a person should have an attribute which is a bank account. So a person doesn't extend bank account. So a person should not be a subclass of a bank account. In one way, object-oriented requires us to write many more lines of codes. It also provides some convenience as in inheritance to avoid writing redundant codes. With polymorphism, poly means many, morphism means forms, Java provides further convenience in code writing. We can use basically the same method names and let the compiler or the runtime Java virtual machine to decide which one it is. So it makes our code cleaner in using names. We will recap what we have seen about compile time polymorphism and go into some detail about the runtime polymorphism. Static polymorphism, that is, compilation can already tell which method is being referred to, even though there are many methods of the same name. This is possible simply because we use different sets of parameters for matching to know which is the right one to use. So we don't have to scratch our head to come up with different names for actually the same method. This is called method overloading. We have seen this for our more than one constructors in the same class, all with the same name as the class name, but each has a different set of parameters. Here is our bank account with two constructors. The first constructor has no parameters, and the second constructor has two parameters, a number and balance. This is method overloading in support of static polymorphism. So during compilation, the compiler can tell which of the methods is going to be used by a particular statement because of the difference in the set of parameters. Dynamic polymorphism, that means runtime to decide which is the right method to use. Recall a superclass reference, that means a variable name can actually refer to an object of the superclass as well as an object of a subclass. Also, a method M can have many implementations due to overriding. M could be implemented in the superclass as well as in the subclass. When we invoke a method M using a particular variable name, which version of the M should be invoked? The M could be in the superclass as well as in the subclass. For example, BA is a bank account, SA is a saving account. Actually, BA is pointing to a saving account. So the printing of BA should actually print out the interest rate as well, as we hope so. This is indeed the case as Java Virtual Machine works as shown in the next slide. R is the reference. When we invoke the method M with r.method, and R is pointing to an object, depending on this object, what M is going to be invoked. Suppose this object is in class C, then we will search the implementation of M starting in class C. If this is found, then the version of M is invoked. Otherwise, we'll move to the superclass of C and repeat the process. So just now, in the banking account, BA is pointing to a saving account object. So the search for the printing will start from the saving account class, which is found, and thus the interest rate is actually printed out, together with the account number and balance. Here is a simple illustration again. We have a bank account BA and a saving account SA. When we first print BA, because BA is a bank account, so this print is the method in the bank account, which prints only the account number and the balance. Now we set BA to be the saving account. BA as a reference is now pointing to a saving account. Then if we print BA, this BA, even though it's a bank account reference, but it is actually now pointing to a saving account due to these statements. The printing of this is searching from the saving account. Thus, this printing also prints the interest rate. It may seem that Java Virtual Machine is smart to resolve the right method to use, as shown in the last slide. But compiler at compile time does not do any analysis on the actual type of the object being done. That is to say that BA, which is declared as a bank account with the method to call pay interest, will cause an error because as a bank account, it doesn't have a method to pay interest. Even though there is a statement before this saying that the BA is now pointing to a saving account. Such kind of analysis is not done by the compiler, and thus it doesn't know that this can actually happen instead of a compilation error. So beware, this will not get through compilation. Compiler doesn't do such kind of semantic analysis. This is the last section of the video. From what we have gone through in the syntax and semantic of Java, you can pretty much reproduce what you have learned with Python in Java, also in an object-oriented manner. This section is to show the complex number class that can be implemented with either the Cartesian coordinate or polar coordinate. Please refer to the PPT for the details, and you can download the source code from the teaching resource links. Here we have reproduced the Python portion as a kind of interface. So all the methods are actually with empty body, except for toString, which has the detail of printing out the complex number. Here is the complex number implemented in the Cartesian coordinate. Here is the implementation in polar coordinate. Here is the testing. Test of the complex number in Cartesian coordinate, test of the complex number in the polar coordinate, test in the combining of the two. You can mix A is Cartesian, you can subtract away from D, which is the polar coordinate. Here is the Java version. Notice that in this interface we can't have explicit implementation. So we don't see a toString implementation as the one in Python, because Java interface has to be purely interface with no implementation detail. Actually, toString is a method of the mother of all classes, the capital O object. So it is actually available without explicitly mentioning it. Here is the Java implementation of the complex number in Cartesian coordinate. Here is the Java implementation in the polar coordinate, and the testing of the complex number in Cartesian, complex number in the polar, and complex number combined. combining A, which is the Cartesian, with the D, which is the polar coordinate. To sum up this video, we have seen object-oriented feature with respect to Java in its encapsulation, inheritance, and polymorphism. For encapsulations, Java does it with class to encapsulate attributes and methods. In inheritance, we've seen that it allows subclass with the use of super keyword to call the supers method, and we have method overriding, and we have subclass substitutability for object reference which are declared as superclass. In polymorphism, we've seen static compile time polymorphism and dynamic runtime polymorphism.